Hello everyone. Our question for today is the following integral: d theta over 4 plus 5 cosine theta. For this class of integrals, I mean for the integrals of the form d theta over a plus b cosine theta, we always apply the following change of variable: t equals to tan of theta over 2. So that's the trick. So we let t equal to tan theta over 2. Thus, dt equals to 1 over 2 times secant squared of theta over 2 d theta, and d theta is equal to this expression. Using the following identity, we end up with the following expression for d theta. For cosine theta, it is well known that it's equal to 1 minus t squared over 1 plus t squared. This is called the half-angle substitution, and later I will dedicate a video explaining how to derive these expressions. Alright. We come back to our integral and it becomes the following. We now use this formula to replace the d theta and this formula to replace the cosine of theta. The next step is to find a common denominator and simplify the following fraction, and we end up with this integral. We can keep it like that, or we can multiply up and down by minus and end up with this integral. How do I do this integral? We apply partial fractioning. Since we can factor the denominator as follows, we can decompose the fraction into the following: sum a over t minus 3 plus sum b over t plus 3. We find a common denominator here, and we end up with this. We cancel both denominators, and we end up with this equation. We can take particular values for t in order to find a and b, and let us consider the zeros of t plus 3 and t minus 3. So for t equal to 3, we end up with negative 2 equal to 6a, and thus a is equal to negative 1/3. And for t equal to negative 3, we get b equals to 1/3. Thus, the integral becomes as follows. We split it up into the sum of two integrals, and now we end up with simple integrals. Negative 1/3 times the ln of the absolute value of t minus 3 plus 1/3 times the ln of absolute value of t plus 3 plus c. One more step is to bring it back to theta. So we replace each t by the tan of theta over 2, and we end up with the following answer.